Okay, let's remind ourselves of the first Pythagorean identity. Once again, many of you saw this earlier on in the discussion of trigonometry, this exact example, but I like to bring it back because it's going to set the stage for where we go. So recall, if we start with the equation for a circle, x squared plus y squared equals 1, and we know on the unit circle x equals cosine theta and y equals sine theta, then we know x squared plus y squared equals 1 gives us cosine theta squared plus sine theta squared equals 1. Notice the way I write the notation, and I didn't really point this out well previously, is I do cosine theta all squared plus sine theta all squared equals 1. Many of you, I'm sure, recall the notation in the books of the notation looking like cosine squared theta plus sine squared theta equals 1. That is correct notation. I don't tend to use it as much just because I find students get confused. That they're really good if you say it's cosine theta squared plus sine theta squared equals 1. And so I tend to use that particular notation. So let's just take a look at one example, and then I'm going to just hit the highlights of the remaining examples here. If I know sine theta is 0.6 and I know theta is in quadrant 1, I want to find the values of cosine theta and tangent theta. What's important here to recognize is that I'm in quadrant 1, and so no matter what I do, I should always get positive values for any of the trig functions. So if I substitute in for cosine theta and sine theta for what I know that sine theta is 0.6, and so if I substitute in the 0.6 for the sine theta, I end up having cosine theta squared plus 0.6 squared equals 1. And if I do all of the algebra out, I learn that cosine theta is either plus or minus 0.8 by the time I do all the algebra. But again, I said I'm in quadrant 1, and so my cosine has to be the positive 0.8. And then I can get the tangent by just doing the ratio of sine over cosine. So tangent ends up being 0.6 divided by 0.8, or 3/4. Now I did more examples, and all I really did was I moved my trig functions into different quadrants. So you'll notice the next example, I'm in quadrant 2, and in quadrant 2 sine is still positive, but what happens when I end up getting the answers for cosine and theta, or cosine and tangent I should say, cosine theta and tangent theta, you'll notice that they both end up being negative because of that quadrant 2. But otherwise the algebra is exactly the same. Likewise, now if I'm in quadrant 3, you'll notice to do the setup I had to make sine be negative 0.6. And remember, in quadrant 3, sine and cosine are both negative and tangent's positive. So again, I did all of the same algebra, came down to the same type of thing. Cosine theta is plus or minus 0.8, but in this case, again, because I'm in quadrant 3, the cosine has to be negative, and then the ratio to get me tangent theta ends up being positive. So those you might want to go back and refresh your memory on. Again, I did talk about them in an earlier section, but this is a good place for you to come back and really convince yourself that you know how to do the problem.